welcome. Today we'll be talking about retriever in LangChain. So in our pipeline we have retriever here, you can see. Now the retriever is a component that fetches relevant document from a knowledge source. This knowledge source can be a Wikipedia, can be a vector store, can be a dataset, a database, can be anything. And here we'll be talking about Wikipedia retriever, vector store, MMR, contextual compression retriever, multi-query retriever. Now what is a Wikipedia retriever? Wikipedia retriever is a retriever class in LangChain that fetches relevant content from Wikipedia. So these are some options that are available in this Wikipedia retriever. So here we have Wikipedia retriever, and if we run this, you can see it is searching the Wikipedia, and it has written two documents because we have written k top k results equal to 2. Hence it has written two relevant documents for this question, that is what is a bagel. You can see here. Now the next type of retriever is vector store retriever. Now this retriever is a wrapper around a vector database, and it retrieves document from a vector database. So you must be thinking, why do we need this retriever when we have similarity search? Here in the previous video we have seen this code, this ChromaDB code. So here you can see we are doing a similarity search and we are getting the relevant documents. So if we have this similarity search, why do we need a vector store retriever? With vector store retriever, we can do a lot more than just similarity search. We can do metadata filtering, we can do custom scoring, we can easily plug it into into LangChain pipeline. We can create multiple, we can compose multiple retrievers. We can write custom retrieval logic. Hence, this is a better option than just similarity search that we have in case of vector database. Now, let's see how it works. Here we have vector store. So first we are reading the PDF here, then we are splitting that into multiple chunks, then we are creating the vector database. You can see we are creating the vector store. Now after creating the vector store, we are using this, we are using the vector store as retriever like this, and here we are saying we need top 3 results or top 3 documents. And when we run this, you can see created vector store. Now you can see we have top 3 relevant documents. So this is how vector store retriever works. Now next we have MMR. MMR stands for maximum marginal relevance retriever. When you use this technique to retrieve documents, the documents will be relevant and diverse. Let's understand by taking an example. Let's say we have these documents in a vector store. Now we have this query: how do dogs help with anxiety? So if we use this without MMR, we might get something like this. So dogs help reduce anxiety by offering companionship. Dog help reduce anxiety by offering companionship and being by your side during tough times. So you can see these two are same. You can see word by word these two are same. So we are getting relevant document, but these are not unique. So to get relevant and unique document, we use MMR technique. So when we use MMR, we'll get separate document. You can see all these documents are relevant and all these documents are unique, and it scores using this formula. You can see here higher lambda value will give more relevant document, lower lambda value will give more diverse document. Now here we have code for MMR. So similarly we are creating the vector store here. Then while retrieving, we are using search type equal to MMR. So this is the difference between MMR and without MMR, you can see. So when we run this, loading PDF, creating vector store, and then we are getting unique documents, you can see here. Now the next type of retriever is contextual compression retriever. So contextual compression retriever is a special kind of retriever that compresses or filters the received document based on a user query to return only the most relevant part of each document. Let's understand by taking an example. So we have these documents in our dataset or in our database. Now this is our user query. What does a beagle look like? It might return something like this. Beagles are small hounds with tricolor coats. They were bred in England for rabbit hunting. You can see this is the appearance info and this is extra info we have. But we need only appearance info, right? This is just a noise. Similarly, we have here, this is appearance info and this is extra info. So when we use contextual compression retriever, it compresses or filters out this extra info. So from here, from these kind of results, we'll be having this. So beagles are small hounds with tricolor coats. So we are keeping only the information that are relevant to appearance. So the pipeline for this contextual compression retriever will be something like this. We receive the user query, we create the base retriever, then after that we retrieve the relevant documents, then we'll pass that to a compressor and it will remove unnecessary information and it will keep only relevant information with respect to our user query. And the compression happens by using an LLM. Same thing, we have documents, then we are creating a face vector store. Then here, this is the vector store with similarity search. And now here we are creating the compression. We are creating the contextual compression retriever. You can see it is using a LLM as a compressor. You can see here. Now when we run this, Python 4, so this is like without compression. You can see we have extra info. After compression we have only relevant info. So this is how this contextual compression retriever works. Now the next type of retriever is multi-query retriever. Multi-query retriever is a clever and powerful tool in LangChain designed to improve the recall of your retrieval system by leveraging LLMs to generate multiple diverse and semantically similar queries from a single user query. It then performs retrieval for each of those queries, merges and deduplicates the results to provide a richer and more complete answer set. Let's take an example to understand this. So if we have this question, what does a beagle look like, and this one, describe the physical appearance of a beagle. So they both talk about the same thing, that is the appearance of a beagle. So user can ask either this question or this question. And the second thing is, this question has multiple interpretations. So this can be describe the physical appearance of a beagle, this can be what are the visual characteristics of a beagle, this can be also how can you identify beagle dog by its looks. So same question has multiple interpretations. To deal with this kind of situation, we have multi-query retriever. So here this receives the user query, this generates multiple queries out of this user query which will be having the similar meaning, and then after that it does the retrieval, and after retrieving document for each query, it merges everything together, it removes duplicate documents, and then finally give the result. So this is the workflow of this multi-query retriever. Now here you can see these are the documents. We are creating face database again. Now here we are using LLM to create multiple queries, and then all the processes that merging and deduplicates happens here. So if we run this, you can see this is without the multi-query retriever, and after using that we have these results. That's it, guys. I think you got a better understanding of retrievers in LangChain. Please like, subscribe and share. I'll see you in the next video. Till then, take care.